riverbeds down to the earth, and there would be an abundance of gold. That's exactly what they did. Around here it was referred to as walking in a jewelry shop, because once you've dug a sufficient tunnel in the right spot, you can pluck gold nuggets from the walls left, right, and centre. There was just that much. About 10 years after the first discovery of gold, so in 1861, the mining company started to set up here. But they weren't looking for any gold nuggets. Find a big gold nugget you can retire on. There's a little bit of skill, a lot of luck involved. A more reliable way to find gold is to look for this instead. This is quartz rock, a natural gold-bearing ore. You won't find any nuggets, but you will find very tiny veins of gold running throughout, thinner than a blade of grass. Not worth much by itself, but if you're able to process this, take the gold out of it, then put it all together, then it is worth something. So the mining companies needed a few things in order to do this. They needed a poppet head, a battery house, and a gold smelting works working like myself. So first step in quartz mining is to dig a very deep hole. Anywhere from 100 meters to a kilometer down, you're going to find quartz reefs. Basically this, the size of this room, or even bigger. You drill into it, you fill it with black powder, you blast it to bits. Bit similar to these sizes here. The miners would then take that over to the poppet head entrance. For those of you that don't know what a poppet head is, it's basically that big tower over there. Once they're at the surface, they're then transferred to the battery house. We have an example of one of those just next door. In there, they are crushed under steam-driven hammers again and again and again, until they become a very fine dust. We then take this dust and wash it over a series of tables. These tables have grooves in them like this. And when the dust is washed over these tables, the gold will sink into those grooves, with the rest of the dust simply washing over the top. That's simply because gold is the heaviest. Another element was added to the table called silver mercury. Mercury and gold have a natural attraction to each other. They like each other very much. So the mercury helps the gold stick to the table that little bit better. The result of the battery house is a thick, sticky paste we call an amalgam. That's where my job comes in. The mining company gives me that amalgam. My job is to remove those impurities. The amalgam is made up of the nickel, the tin, the iron, the copper, the silver, and now mercury as well, and also, most importantly, the gold. So first of all, I try to remove that mercury. I do that by placing it in a fancy cast iron pot, like this one here. This is called a retorse. Place the amalgam in there, bolt it shut, place it into the furnace. 358 degrees later, the mercury will turn into a gas and escape out of this pipe here, flooding the room with toxic mercury gas. Not sure how many of you are aware of the dangers of mercury poisoning, but it can cause your teeth to fall out, cognitive issues, memory loss, kidney failure, death. Your teeth can fall out, memory loss. Cognitive issues, your teeth can fall out, memory loss. Kidney failure, death, memory loss. So they made a little, once they became aware of the dangers of mercury poisoning, they made a little addition to what we call a retorts here. They extended the pipe, and that pipe would extend into a cold bucket of water. The mercury would still come out as a gas, but once it hits that cold water, it turns back into a liquid, storing that mercury in the bucket, preventing the mine blacksmiths from breathing it in, and also being able to reuse that mercury back in the battery house. So win-win scenario. I then take what's left of the amalgam and place it in a crucible, much like this one here. I then chuck the amalgam in the crucible, and then on top of that amalgam I place a powdered flux called borax. This acts as a collector, and for intended purposes, borax is very much the opposite of mercury. It'll stick to everything, but it won't stick to the gold. I then place that into the furnace and heat it up to 1064 degrees. At that temperature, that's gold melting temperature. At that stage, everything in there will be a liquid, which is what my gold is just heating up to now. All of those light impurities will be bubbling to the top and getting stuck to that borax, forming a crust. I can then simply scrape off that top crust layer if it's bubbling over the top, or I can just start to pour. And as I pour, the gold will come out first, and that crust will will just float to the back like froth when you're drinking a milkshake or something. So my gold is reached 1,064 degrees. If I took it away from the heat source right now, it'd immediately start turning back into a solid in the crucible. I need to take it right up to 1,200 degrees. It'll allow me about 10 to 15 seconds to come over the table and pour it out before turning back into a solid. If you want to record this part, get your devices out now. And also don't come any closer or stand up, stay secret, as it's not the safest thing in the world. So this silicon here is made of carbon, graphite, silicon. Silicon makes it glow and look really pretty, which you saw. What they would have used back in the day would have been a single use just made out of clay. And all those impurities that got stuck in the crucible, all precious materials today, they would all just been thrown in a pile because of profiting the gold that much. Didn't really worry about it at all. In just this brief amount of time, the gold has transferred 300 degrees worth of heat into the mold. Back into a solid. This is still well over 900 degrees. If this was made of anything else, you'd all be able to feel the heat coming off it in the front row. But you can hold your finger or your nose just a millimeter away from it, and it's still going to feel a very faint heat. That's because gold transfers pretty much all of its energy via touch or conductively. It has a very difficult time radiating that heat, like you're sitting around a fire. This could sit like this for the next 3 hours before it's safe enough to touch, just holding on to that heat. And I haven't had my lunch yet, so see you later. Just kidding, we'll give you another way to transfer off that. But I will demonstrate just how much energy this has. Some of you in the front row there might try to imagine jumping the fence, grabbing it, running down the door with it. You wouldn't make it halfway the steps before it melted through your hand. As soon as you give it something to transfer that energy to, it will do so with gusto. Instantly combusting. So, I need to give it another way to transfer off that heat. I have a big trough of water here, luckily enough. So let's do it. Alrighty, let's talk about the water first. The water could be one of three things: hot, warm, or cold. I just put a 900 degree block of gold in it. Hands up if anybody thinks the water is going to be hot. No. Hands up if you think the water is going to be warm. Hands up if you think the water is going to be cold. Hands up if you just don't know. Well, let's find out. The water is actually ice cold. The rate of heat transfer was that rapid that all the water that the gold touched instantly evaporated. All that energy that was in the gold bar is now in the room around us. The safest way to figure out if the gold is safe enough to touch is simply to get somebody else to pick it up for you. I'm going to take it. So I'll pick it up just like I have 100 times before.
원들어졌어.
This is 24 carat, 99.99% gold, 3 kilograms or 100 troy ounces using the old scale. It's a soft metal, you can put a shit into just like that. Very heavy. This quartz rock and this block of gold weigh about the same. That's how dense it is. This would then get stamped with the company logo and then taken out to Melbourne, guarded by Red Coat soldiers to be sold at auction or melted down for sovereigns. In today's value, it's currently worth $310,000. Very shiny. It's also not mine. And sovereign God has 310,000 reasons why I can't pass it around for each and every one of you to hold. That's the end of the demonstration. Thank you all for coming along. Enjoy the rest of your day. Follow me out to Dr. Walker.